Good morning, dear students. So in the last class, we have seen the nomenclature, right, of aldehydes and ketones. So we know how to write the common names and the IUPAC name for aldehydes and the common your ketones, right? So we have seen some of the examples. Then today we are going to start with what? We are going to start with the preparations, okay? So before going for preparations of aldehydes and ketones, so let us see the structure of carbonyl group. So these are the things which we have already dealt in our previous class. Okay. So let us see today the structure of carbonyl group. Yes. Okay. So how is the carbonyl group? C double bond O. Right. So this is a carbonyl group. So here the carbonyl carbon, this particular carbon, what is the hybridization? Can anyone tell me what type of carbon? It is called as the carbonyl carbon because this carbon is involved in double bond formation with oxygen, right? So this is called as a carbonyl carbon. So this carbonyl carbon, can anyone tell me uh, what is the hybridization of this carbonyl carbon? Yes, very good. It is sp2 hybridized. Okay, so it is sp2 hybridized. Okay, so how many sigma bonds are formed here? Yes, how many sigma bonds are formed here? Just a second. Yes, how many sigma bonds are formed here in the structure? Four. No, not four. In this structure, you can see three sigma bonds are formed, right? So one, I'll show you, I'll represent. So this is one sigma bond, another sigma bond, one sigma bond. This is a pi bond. Okay, when you have double bond, one will be a single bond, another will be a double bond. If you have triple bond, okay, one will be a sigma bond, other two are with the pi bonds. Okay, so here you have how many sigma bond? Three sigma bonds are there. Okay, and these all lie in a plane. So you can see which are the three sigma bond. So this is one sigma bond. Okay, so the bond between the two, this what is that? So when so here one p orbital of another atom will overlap with the p orbital of this. So p orbital of carbon will overlap with the p orbital of the next alkyl group. So here, okay, overlap will takes place. One will be in between the okay, it will be a sideway overlap and another will be a axial overlap. Okay, so whatever the unhybridized p orbital is there. So now how the sigma bonds are formed? Now see, when you consider two carbon atoms, okay, so this is one sigma bond, then this is one sigma bond, and this is one sigma bond. Okay, now suppose if I take like this, carbon. Suppose, so this is a carbonyl carbon. Okay. So one sigma bond here, one sigma bond here. So this is the unhybridized, what is that? You say unhybridized p orbital. So unhybridized of p orbital of this carbon will overlap with the unhybridized orbital of the another carbon and it will form what? It will form a pi bond. So like this, the pi bonds are formed. Like this, the pi bond is formed. Okay. So how is the pi bond formed? By taking the unhybridized orbital. You can see here, right? So one of the p orbital, which is unhybrid, so unhybridized, it will get combined with the next carbon atom. Okay, so two k orbitals, unhybridized p orbitals will overlap with each other to form a pi bond. So unhybridized p orbital overlap with the p orbital of oxygen atom, and thus what they'll form? They form a pi bond. So this pi cloud, it is one is above the above you can see, and one more is below the plane of the molecule. So if you consider a molecule, one of the pi bond is above, another is below the plane of the molecule, and the angle. Okay, so how this looks? So suppose this is a carbon, okay, and this is a oxygen. Now here, so one will be a like this, okay, like this. So this forms one pi bond, and this is another pi bond. Okay, so this is another pi bond. So like this, you can represent your structure. Okay, so what is the bond angle? Coming to the bond angle, so carbon, double bond, oxygen. So the bond angle between the carbon and oxygen is 120 degree. Okay, it is 120 degree. So oxygen, it has its lone pair of electrons. So the angle between these atoms are 120 degree. So the bond angle is approximately 120 degree, and it has a planar structure. Okay, it has a planar structure. And we know that the CO bond, okay, whenever you have a C double bond O bond, so this is what? Because of the presence of oxygen atom, it is highly electronegative atom, right? So oxygen is a highly electronegative atom. So as a result, what will happen? The atoms will get polarized, right? The atoms will get polarized. So oxygen will get a partial negative charge, and carbon will get a partial positive charge. So as a result, what will happen? There will be development of charges. There will be development of charges occurring like this. So carbon will get a positive sign, and oxygen will get a negative sign. So this is about what? This is about your carbonyl compound. Okay, so this is a carbonyl group. So how the carbonyl group? So how it forms the bonds. Okay, so this is explained by the structure of functional group. So what happens here? So carbonyl group, okay, the carbonyl carbon here, it is sp2 hybridized. What all you need to remember? So the carbonyl carbon is sp2 hybridized. Okay, so it forms how many bonds? It forms three sigma bonds. Okay, it forms three sigma bonds, and these sigma bonds, they lie in a plane. You can see that there are three sigma bond, and these three sigma bond, they lie in a plane. So one, two, and three. So one of the p orbitals, okay, so unhybridized p orbitals will overlap with the unhybridized p orbitals of the oxygen atom, and it forms what? Pi bond. The pi bond formed will be, one will be above the plane, another will be below the plane, and thus, okay, so the bond angle between these atoms is 120 degree. Okay, so because of the presence of carbon and oxygen atoms, so oxygen is highly electronegative atom. As a result, what happened? The bond polarization takes place. As a result, oxygen will get negative charge, and carbon will get positive charge. So thus, okay, so your so because the carbon oxygen double bond, it is polarized, okay, because of the electronegativity of what? Because of the electronegativity of the oxygen. Okay, as compared to carbon, oxygen is highly electronegative. So this will get a minus sign, this will get a positive sign. Okay, so carbonyl carbon, it is electrophile nature, and it has a Lewis acid. Okay, it has Lewis acid because it will accept a proton. Okay, and carbonyl oxygen is a nucleophile. Okay, it acts as a Lewis base. Okay, so like this, this is the what you say, structure of carbonyl group. Okay, so like this we can explain the structure of the carbonyl group. So here, just now, whatever I have shown you, so this is the thing. Okay, so three sigma bonds. You can see these are the three sigma bonds which are in the plane. Okay, and then it forms what it forms. It forms the so one of the unhybridized orbital. Okay, of the carbon and oxygen. They will what they will overlap. Okay, so they will form pi bond above the cloud and one pi bond that is above and below the this molecule. Okay, so thus like this you can see. So the hybridization of carbon, as we discussed, it is sp2 hybridized, and oxygen is also sp2 hybridized, right? So the bond angle between these atoms is 120 degrees. So like this, they form the hybridization. Okay, so these things you have to remember. Okay, so let us start. Next is with the preparation of aldehydes and ketones. Okay, next we'll start the preparations of aldehydes and ketones. So how we can prepare aldehydes? Okay, don't forget what is aldehyde. Aldehyde is RCHO. Okay, and ketone is RC double bond O R dash. So your R can be any alkyl or aryl group. Okay, so remember these things, don't forget. Then, so first we'll see by oxidation of alcohols. By oxidation of alcohols. So these are the reagents. So these are the best oxidizing agent, that is potassium dichromate. K2Cr2O7 is potassium dichromate. Okay, K2Cr2O7 is potassium dichromate. Okay, so potassium dichromate in the presence of H2SO4, that is your sulfuric acid. Okay, sulfuric acid. So what happens here? What we are doing? We are doing a controlled oxidation. Control means we are controlling the reaction. Okay, we are going to do a controlled reaction. So by supplying so much amount, so we can what? So alcohols, corresponding alcohol. Suppose by taking a primary alcohol, okay, if you do oxidation, okay, if you take a primary alcohol and if you do oxidation in the presence of K2Cr2O7 and H2SO4, we get a aldehyde. So whenever we have a primary alcohol, so primary alcohol, if we treat it with K2Cr2O7, that is a good reducing oxidizing agent. Okay, what it will do? It will remove your hydrogens, okay, and addition of oxygen. So it results into what? It results into a aldehyde. So you can see what is there. Here H2 is removed. Here there is only RCHO. RCHO, right? So your hydrogen is removed. So primary alcohol, if you take a primary alcohol and if you do a controlled oxidation by taking oxidizing agents such as potassium dichromate in the presence of sulfuric acid, what you will obtain? You will obtain the aldehyde. What you will obtain? You will obtain the aldehyde. So let me give you an example. Okay, so let me take, which is this alcohol? Can anyone tell me which is the alcohol I've written? Yes, which is the alcohol. What is the name of the alcohol, students? What is the name of the alcohol? Don't know? CH3CH2OH. It is a ethyl alcohol, right? Or it is a ethanol. Okay. So ethyl alcohol, if you treat it with K2Cr2O7 in the presence of H2SO4, can you tell me what will be the product obtained? Can you tell me what will be the product obtained? What will be the product obtained? Yes, please reply. Use your chat box for answering. Are you able to hear me? Yes. Then why you're not answering? Don't know what will be the product. So if you take a ethyl alcohol, try, at least try. So ethyl alcohol and if you treat it with your, okay, H2, K2Cr2O7 in the presence of H2SO4, okay, which is a good oxidizing agent. What we are going to do, we have seen that there will be removal of hydrogen. Okay, so what will be the product?
CH3.
Yes, CH3CHO, right? So it is what? What is the name? It is a acetaldehyde. It is a acetaldehyde plus H2O plus H2O. Okay, so this is the compound. So like this. So if you take what is controlled oxidation? So if you take a primary alcohol and if you treat it with this particular reagent, you'll yield a aldehyde itself. Okay. So this is a with respect to primary. If you take a secondary alcohol, so secondary alcohol, you can see there are two R groups, right? Two, it can be any alkyl groups or it can be any aryl groups. So if you take a secondary alcohol and if you treat it with again K2Cr2O7 in the presence of concentrated H2SO4. So here in the primary alcohol, we are using dilute acid. Okay, we are using dilute H2SO4. In your secondary alcohols, we are using concentrated H2SO4. Why? Because we want to convert our secondary alcohol into ketone. So because of that, we are doing a what? It is called as controlled oxidation. Okay, in primary alcohol, we have to we have to convert it into aldehyde. So we are taking dilute H2SO4. As we want to convert our secondary alcohol to ketone, we are going to use what? Concentrated H2SO4. Okay, we are going to use what? Concentrated H2SO4. So let us see. So if you take a secondary alcohol and if you treat it with what? If you treat it with your this what your H2SO4 and this K2Cr2O7. Okay, what I'm going to get? I'm going to get a ketone. I'm going to get what? Ketone. So both these hydrogens are removed. Okay, let us see example. Let us see example. So CH3, CH, CH3, OH in the presence of K2Cr2O7 in the presence of H2SO4. Yes. Can you tell me the answer now? Yes. What will be the answer? Not understanding. Yes. Did not understand. Okay, fine. See here, what we are doing, we are preparing our aldehyde and ketones. Okay, how we are going to prepare our aldehyde and ketones? By taking alcohol as the reactant. Okay, so we know now what is a primary alcohol. This is a primary alcohol, right? So direct to the OH group, you have only one alkyl group attached, then it is called as primary alcohol. Then if two alkyl or aryl groups are attached, okay, then this is what? This is a secondary alcohol. Then, if three alkyl groups or aryl groups are attached, then it is what? It is a tertiary alcohol. Now, what we are doing? We are doing a controlled oxidation. Now, what is the meaning of oxidation? Controlled oxidation. Okay, controlled means we are doing some conditions. Okay, conditions are applied. Okay, for okay some conditions are applied. So we are doing control oxidation. What do you mean by oxidation? Oxidation is addition of oxygen, okay, or addition of oxygen or removal of hydrogen. This you know, right? So addition of oxygen or it is removal of hydrogen. Now here, when we are talking about controlled oxidation, okay, we want to prepare aldehyde and ketone. So if you take a primary alcohol, if you take a primary alcohol and if you treat it with potassium dichromate, okay, K2Cr2O7, it is nothing but it is a potassium dichromate, and this potassium dichromate, it is a good oxidizing agent. Okay, it is a good oxidizing agent. So what it will do? Potassium dichromate, so potassium dichromate in the presence of H2SO4. Okay, H2SO4 is what? It is an acid. So here we are taking dilute H2SO4. Okay, what we are taking? We are taking dilute H2SO4. Okay, so when we are treating our potassium dichromate with H2SO4, okay, so what we are going to get? We are going to get a aldehyde. So either we can remove hydrogen or we can do we can add oxygen. So depending upon okay, what we are going to get? We are going to get a aldehyde. So what we are doing here? So here the hydrogens from here it is removed. Okay, the hydrogens are removed from here. What I will obtain then? RCHO. Right, RCHO. So this is what? This is a aldehyde. What we got? We got a aldehyde. So potassium trichromate is a good oxidizing agent. What is the role of oxidizing agent? Yes, what is the role of oxidizing agent? It oxidizes other. Okay, it oxidizes other and itself undergoes reduction. Okay, itself undergoes reduction. So remember this. Okay, the important definitions. So what is oxidizing agent? It oxidizes other and itself undergoes reduction. Means what? It oxidizes other means what? In it oxidizes other means it will so it will oxidizing other means there will be loss of electrons. Okay, and it will undergo itself oxidation. Okay, that is reduction. Reduction means there will be addition of, don't get confused or else, okay. So just remember these two definitions. That is about your oxidation and reduction. What is oxidation? Addition of oxygen or removal of hydrogen is called as oxidation. So when we take a primary alcohol and if we treat it with K2Cr2O7 in the presence of dilute H2SO4, we get a aldehyde. So if you remove this H2 from here, what I'll add yield RCHO. Okay. So this is a aldehyde. We get a aldehyde. Then if I give you example now, CH3, CH2, CH2OH. Okay. In the presence of K2Cr2O7 and H2SO4, that is dilute H2SO4. What will be the product now? Can anyone tell me what will be the product now? What product will be obtained now? Yes, what will be the product obtained? Okay, propanaldehyde. What I'll get? I'll get a propanaldehyde. So H2 is removed. Okay. H2 is removed. So what we got? We got a propanaldehyde. This can also be written as CH3, CH2, CHO. Okay, don't get confused. So it can also be written as this. So it is what? 1, 2, and 3 carbons. So it is a propanaldehyde. Okay, propanaldehyde. Is it clear now? Understood? Yes. Is it clear? Okay, fine. So this was about your primary alcohol. Now if we take a secondary alcohol. So secondary alcohol, so this is a secondary alcohol. We are doing oxidation in the presence of K2Cr2O7 and concentrated H2SO4. Okay. We are going to take what? We are going to take concentrated acid, concentrated H2SO4. So when we treat our secondary alcohol with concentrated H2SO4, what we are going to get? We are going to get a ketone. We are going to get what? We are going to get a ketone. R dash OH. Okay, we are going to treat it with K2Cr2O7 in the presence of concentrated H2SO4. So what we are going to get, see, so just remove this hydrogen. Okay, both this hydrogen. We are going to get R dash C R double bond. Okay, so this is a ketone. This is a ketone. So let me give you example. What I'm going to get. Okay, so I'm going to get what? Acetone. The name of this ketone is acetone plus H2O. Okay, plus H2. So this is a isopropyl alcohol. This is a isopropyl alcohol. From isopropyl alcohol, what we are going to get? We are going to get a acetone. Okay. So this was the first method of preparation of aldehydes and ketone. So by doing controlling the oxidation, this reagent, we are going to get aldehydes and ketone. So remember what you have to remember: primary alcohols, when they are treated with K2Cr2O7 in the presence of dilute H2SO4, what we get? We get a aldehyde. So remember this points. Okay, please make a note. And secondly, when secondary alcohols are treated with K2Cr2O7, okay, in the presence of concentrated H2SO4, what we are going to get? We are going to get a ketones. Okay, we are going to get what? Ketones. Is it clear? Okay, fine. Others, others have understood? Harshita, Lubna, Navneet, Sharan, Saubhagya, Srivarun, Baby. Others have understood? Yes, okay, fine. Okay. So let us proceed further. So the next is dehydrogenation reaction. Next is what? Dehydrogenation reaction. What do you mean by the word dehydrogenation? Please write down the meaning. Okay. So when you are making the notes, okay, short notes. So please write down the meaning of these words. Okay. Because yes, removal of hydrogen. Very good. Who has answered it? Yes, very good. Baby has answered it. So dehydrogenation means removal of hydrogen. Yes, very good. So removal of hydrogen. So what we are doing when okay, so what we are doing when the vapors of primary or secondary alcohols are passed over heated copper. Okay, so what we are doing, either we are taking a primary alcohol or secondary alcohol. So primary alcohol, when it is treated with the this what copper. Okay, we are heating the copper at 573 Kelvin. So what happens? Dehydrogenation takes place. What do you mean by dehydrogenation? removal of hydrogen. Okay, removal of hydrogen. Yes. So what happens? So when we have a primary alcohol and if we treat it with copper, okay, we are heating a copper, heated copper we are heating the copper at 573 Kelvin, okay, 573 Kelvin and we get a aldehyde. So this is a acetaldehyde. This acetaldehyde is what you can obtain. How you can obtain? By dehydrogenation. Dehydrogenation means what? Removal of hydrogen molecule. So here H2 molecule is removed and we get a acetaldehyde. Similarly, when we have a secondary alcohol, okay, with secondary alcohol, when you treat it with the copper and if you heat with copper at 573 Kelvin, what we are going to get? We are going to get a ketone. So these two hydrogens are removed. So it yields into removal of hydrogen molecule and we get a ketone. So which is this ketone? It is a acetone. It is a acetone is the ketone which is used. Plus hydrogen gas is liberated. Plus hydrogen gas is liberated. So please make this note. Okay. So please make this note. So can you tell me? Let's see, if we have any. Okay, fine. So is it clear about dehydrogenation? So please make down the note. Very important. So dehydrogenation can be carried out when you treat it with uh, copper, okay, at 573 Kelvin. So here the temperature is important. Here the temperature is important. So this you have to remember. So whenever dehydrogenation is taking place, you have to remember copper, it is heated at 573 Kelvin. Okay. Let us go for the next one. Next is, so the first two we have seen from alcohols, right? First one was by doing oxidation of alcohols. Okay, oxidation of alcohol. Second one was what? Dehydrogenation. Dehydrogenation. Okay, so dehydrogenation of alcohols itself. So by taking alcohols and if we do dehydrogenation, we get aldehydes or ketones respectively. And when we take in the oxidation process, primary alcohol will undergo oxidation to give you aldehyde, and secondary alcohol will give you ketone. Okay, so these things you have to remember. Next, the third preparation is by from hydrocarbons. Okay, from hydrocarbons. From hydrocarbons, we can do this. So the from hydrocarbons, what we can do? So these are the hydrocarbons, right? So what we are going to do? We are going to do ozonolysis. What do you mean by ozonolysis? Ozonolysis. Okay, we are going to do ozonolysis. So ozonolysis means we are going to add ozone molecule across the double bond. So across this double bond, what we are going to do? We are going to add a ozone molecule. Okay, across this double bond, we are going to add ozone molecule. What is ozone? What is the formula of ozone?
O3.
Ozone O3, yes. So we are going to add a molecule of O3, okay, across the double bond. So let us see. So ozonolysis of alkene. So from hydrocarbons. So this is important from CT point of view as well as from board point of view. Okay. So what this tells you? This tells you the position of double bond in the alkene. So we are going to take alkenes here. We are going to take alkenes. Alkenes means what? Alkenes means they are the unsaturated compounds with a double bond. So unsaturated compounds with double bond. Okay. So they are the alkenes. So RCH2, okay, you add a ozone molecule. So how I'll just show you a RCH2, add a ozone molecule. How you'll obtain? So RC, okay, then OCH2, O. So we added a ozone molecule. Now what will happen? So this formation of this such compound, okay. So this is called as ozonide. What it is called as ozonide. So this intermediate, whatever is formed, it is called as a ozonide. Okay, ozonide. So what will happen? So there will be a cleavage like this, and and the other molecule it will cleave like this. So like this, one cleave and another molecule, it will cleave from here. Or you can, okay, what you can do, you can remember like this. So these two bonds are broken. Okay, you can remember like this, it will be better. So like this. Okay, so like this, two bonds are broken, like this, two bonds are broken. Okay. Now what we are going to get? Now what we are going to get? We are going to treat it with zinc dust. We are going to treat it with zinc dust. And what we obtain, we get a RCHO. Here you can see, I'll get a RCHO. Okay, so zinc dust in the presence of water. Okay, in the presence of water, we are going to get aldehyde RHO. Okay, and C, this is a formaldehyde. So formaldehyde is a common product which we are going to obtain when we are doing ozonolysis. So this is a common product. This will change. This will change. So this is a common product which we are going to obtain when we are doing ozonolysis of alkene. Okay, this is formaldehyde. This is what? Formaldehyde. This is a formaldehyde. So what we are going to do, we are going to take a alkene. We are going to add O3 molecule across the double bond. So what will happen? So here one oxygen and here oxygen like this. Okay. So bond is broken here one and here one. So we are going to get RCHO. We are going to get RCHO and we are going to get CHCHO. Okay. RCHO and we are going to get this. So like this, we are going to get the alkene. Okay. So this is the product obtained when we are doing ozonolysis. Next is when you have a, here we can see, so here we have a, okay, two alkyl group substituted alkene. Okay, two alkyl group substituted alkene. Same way, same procedure. So I'll write it here. I'll show you stepwise. Okay, so how it will be. So R, C, R, H double bond, CH2 plus O3 molecule. Okay, when we add this O3 molecule, so what happens? R, so rest all the molecule will be same. Okay, rest of the molecule will be same. So I'll write like this. Let me see what I'll get. Okay, CH2, then O, 1, 2, 3, 4, 5. Right. So see here, actually this hydrogen is present, but carbon should satisfy its valency. Okay, so because of that, we are removing the hydrogen from here. Okay, because the new bond is formed between oxygen. So this hydrogen carbon bond is broken. Okay, now here, now what will happen? One bond will be cleaved here. Okay, I'll take another color. One bond will be cleaved here. Another will be cleaved here. So like this, and the other will be cleaved here like this. Or you can remember like this. So here one and here one. So what you will get? So this particular bond, what you can see, it is HCHO, right? And here what I'm going to get is R dash, okay, R dash, R dash, R dash, C double bond O. R dash C double bond O. So we are going to get a ketone. We are going to get ketone. So whenever there is a branched alkene, so this is a branched alkene, right? So we'll get ketone. Whenever you have unbranched alkene, so this is an unbranched alkene, we are going to get what? Aldehyde. So depending upon the alkenes, whatever you are going to take, we are going to yield aldehyde or ketone. Okay, so first add ozone molecule across the double bond. We are going to get what? Ozonide. Okay, this ozonide, what we are going to do? We are going to treat it with zinc dust in the presence of water. Okay, we are going to get ketone and aldehyde, formaldehyde. So this formaldehyde is a common product. Okay, this is a common product. So is it clear? Is it clear? So very important, ozonolysis. Okay, ozonolysis is very important. Let me give you example. So you have to tell me, yes, use this and tell me. Yes, you can use this and you can tell me what will be the product. What will be the product? So CH3, C, oxygen here, CH2, oxygen here, oxygen here. So this is a ozonide. Okay. This ozonide, we are going to treat it with zinc dust in the presence of water. So like this, and okay, like this. The bonds are broken, right? So what we are going to get? CH3, CH3, CHO plus HCHO. Is it right? Propene ozonide. Don't tell me ozonide. Okay. Ethanol. Yes, ethanol is produced. Very good. So this is a ethanol and a formaldehyde is produced. Yes. Sorry. Ethanol, no, acetaldehyde. Yes. Acetaldehyde. Okay. So it is a acetaldehyde and not ethanol. Okay. So this is a acetaldehyde. Let me give you another example. Yes. This here, what will be the product? So like this, you take different examples, then only you will be understanding the concept. Okay. Take different example, then only you can understand the concept. So again, CH3, CH2. So rest of the molecule you have to write same. Only across the double bond, what you have to do? You have to add the ozone molecule. So this is a ozonide. Okay, this is a ozonide. This I'm going to treat it with zinc dust. I'm going to treat it with zinc dust in the presence of water. What I'm going to get? So one bond will be broken here and here. Okay. CH2, CHO. Okay, CHCHO. CH2, CHO. Here one bond break, here one bond. CH3, CH2, CHO. Okay. And another here HCHO. So this is your compound. Okay, got it? Is it clear? Is it clear? Okay. Now you have to tell me for this. Hmm. Okay, tell me for this. This is the ozonate. Hmm. This I'm going to read with zinc dust in the presence of water. Yes. Can you tell me? So, okay. So like this, the bond is broken. Yes. What will be the product? CH3, CH2, C, CH3, double bond O plus, is it? Is it? Are you getting the same? Are you getting the same? Yes. Okay, fine. Others? So practice, take any R or R dash groups and you will get, so whenever you have, what is the main thing you have to remember? Whenever you have branched alkene, you will get ketones. Okay, main thing you need to remember, whenever you have unbranched, okay, you will get aldehydes. You will get aldehydes. Is it clear? Is it clear? So this was about ozonolysis. So ozonolysis is very important. Next is from alkyne. Okay, alkyne is what? So this is also important. Okay, so this is also important. So let us do this in the next class, okay? Because this will take more time. So just I will read out. So what we are doing, we are going to do hydration. What do you mean by hydration? What we are doing, hydration means? Hydration means, yes, no, addition of H2, not hydrogen, addition of H2. Hydrogenation means addition of hydrogens. Hydrogenation means addition of hydrogen. Dehydrogenation means removal of hydrogen. Okay. And hydration means hydration. Okay. Means addition of water. And dehydration means removal of water. Dehydration means removal of water. Okay. So this is, you have to remember, very important. Fine. So what we are going to do, we are going to take a triple bond alkyne. So this is acetylene. So we are treated with water in the presence of H2SO4 and 1% HgSO4. Okay, that is mercurous sulfate. So what we are going to get? We are going to get a enol form. Enol means what? In and all. Means you have a alcohol and one double bond. So this is called as enol form. So this is undergoing a tautomerism. It is called as tautomerism. Means what? The molecular formula remains the same. Only you can see that in enol form, you have a double bond and a alcohol group, and it will go from enol form to keto form. So it is forming a keto group. So this is called as tautomerism. It is called as what? Tautomerism. So when I take ethyne, so this is a ethyne molecule. So when I form ethyne and when we add water molecule, Okay, it will give you what? It will give you acetaldehyde. So it will undergo a tautomerism, that is ketoenol tautomerism. Okay, so and it will give you what? Keto form. So it will give you a acetaldehyde. Similarly, if you take formaldehyde, okay, if you take formaldehyde, we cannot prepare if we take formaldehyde. Okay, so we cannot prepare formaldehyde from this method. Formaldehyde is what? HCHO. So this aldehyde cannot be prepared. So except formaldehyde, we can prepare any aldehyde or ketones. Okay. Now here, if you take here, okay, so here one more example they have given. So whenever we take acetylene, only acetylene, you will get aldehydes. Other than acetylene, if you take any other alkynes, that is molecule with a triple bond, then you will get ketone. Okay, you will get a ketone. So this example and the explanation, let us see in the next form, next class. Okay, so keto, it will undergo a ketoenol tautomerism. Okay, tautomerism. So the molecular formula will be same. So it can undergo a ketoenol tautomerism. That is, it is having a double bond and alcohol, and this can be, it can form a this also what? Keto group also. So this is called as ketomerism. So about alkyne, let me explain the preparation in the next class. Is it clear? Any doubts up to here? Any doubts up to here? So we have seen today three preparations. Okay, we have seen first by doing a controlled oxidation. Okay, on alcohols, we can yield respectively aldehydes or ketones. Okay, then secondly, we have discussed by doing the ozonlysis. Okay, by ozonlysis of alkenes. Then we have discussed about dehydrogenation of alcohols. Okay, by using copper. Okay, by heating the copper at 573 Kelvin. And this is the last one that we will see in the tomorrow's class. Okay, after that, we are going to see preparation. Okay, preparation of only aldehydes respectively. So here, so these were four important preparations in which we can prepare both aldehydes as well as ketones. Then we are going to discuss how we can prepare ketones only, how we can prepare aldehydes. So that we will see in tomorrow's class. Okay, is it clear? Is it clear up to here? Okay, fine. So I'll end the session here. Okay, we'll meet in tomorrow's class. Thank you. Have a good day.